now is I'm going to concentrate on teaching you guys about acid and base nomenclature. I will not be going into the properties of an acid and base on the test. I will be doing that in semester 2. So if you remember the presentation with Mr. Truesdale, he talked about acids and bases, and he did that great, crazy color change, Boilermaker experiment or demonstration. That's what he was talking about. Anyway, all you're responsible for knowing on the test is how to recognize that the ionic compound, because acids and bases are both ionic compounds, how the ionic compound that you are looking at the formula of or the name of, how do you get... Sorry about that, I should have waited until the bell rang. If I give you the name of the acid, how do you get the formula? And if I give you the formula, well, how do you know how to name it? So that is what today is all about. So, if I give you the name, how do you get the formula? Well, there's 3 types of acids, bases, or actually 2 types of acids, and 1 type of base that I will hold you responsible for on the test. So, we have acids that when you look at the formula, when you look at the name, they do not contain oxygen. That's type 1. The second type of acid we have are those that do contain oxygen. So looking at the name, how do I know that it has oxygen or does not have oxygen? And then of course we have our hydroxide bases. Now those are fairly easy to name because they're going to be made up of a metal ion combined with a hydroxide polyatomic ion. So the name and the formula, if you remember how to crisscross that is, are fairly easy to get. So the first type of acid we're going to look at are those acids that do not have oxygen. So how do I know it does not have oxygen? Well, if I look at the name of the acid, it starts with the prefix hydro. Hydro, and then it ends, its last name is acid. So it's part of its first name is hydro, and its last name is acid. So that tells me this is an acid that does not have oxygen in it. Now, if I go back to the name, following the prefix hydro, I see iodic. Well, if I think about it, iodic sounds an awful lot like iodine. Now, how do I know it's iodine? What you are looking at when you have an acid is you are looking at hydrogen combined with another non-metal. So that kind of limits where you need to look on the periodic table. You are only looking at a few elements on the right side of the periodic table. So you can ignore all the metals and concentrate only on the non-metals. Now the other thing is noble gases do not form acids. So you can eliminate all of column 18. Mainly what you will see on the test and in your textbooks is hydrogen combining with members of column 16 and column 17. So oxygen, well, we call oxygen and hydrogen water, so that kind of eliminates that. Sulfur, and then of course all of the halogens, so chlorine, fluorine, bromine, iodine. So it really limits where you need to look on the periodic table when you're dealing with your acids that do not have oxygen. So we have iodine and hydrogen. So here is our formula for the hydrogen ion. Hydrogen in an acid will have a positive 1 charge. So we have our positive 1 charge for the hydrogen, and then iodine has this symbol of I with a negative 1 charge. If I remember how to crisscross, well, they're the same charge, so they kind of cancel each other out. And this is the formula for hydroiodic acid. Again, to recap, I know that this acid does not have oxygen because it starts with hydro and it ends with acid. Okay? Now, the second type of acid I have are those that have have oxygen. And how do I know that? Well, it does not have hydro in the beginning part. So if you notice the name is phosphoric acid, that tells me that this acid has oxygen. All right? So if I look at it, well, you're like, Mrs. Cray, it says phosphoric acid. How does this name tell me it has oxygen? Well, other than it doesn't have the hydro in front, That's pretty much the only way you know this is an acid that does have oxygen. Now, what else does it have? Well, for this compound, I have two different variations. I could have an acid that ends in IC, or I can have an acid that ends in OUS. So I know what you're thinking right about now is, how do I know that my acid ends in IC, and how do I know it ends with OUS? By the way, what you see me doing right now is I caught a little bit of a mistake on my example. I wrote the formula and the name for two different acids. So I'm correcting that right now. Give me a second. So sorry to turn my back to the camera, but I am just about done. Okay, so I have phosphoric acid. Because it doesn't have hydrogen and I know it has oxygen, what I need to do is I need to pull out my handy dandy polyatomic list. All right? So what I'm going to do with this list is I'm going to look for the component of this compound that has a similar prefix to the name given. So if I look at it, I see phosphoric. So that kind of sounds like phosphorus. But I'm looking at a polyatomic ion, and when I do, I notice I have two choices. I have phosphate and I have phosphite. So how do I know, do I use phosphate or do I use phosphite? Well, if it ends in IC tells me to use the ATE ending, or a polyatomic. So ic becomes 8. So I select the polyatomic ion phosphate for phosphoric, and then of course I crisscross the charges. And the 3 here, I take off the negative and it becomes the subscript for the H. And this 1 here, well, I don't write ones, so it just disappears. Okay, because I only need one phosphate ion. Now, in the case of phosphorus acid with the OUS, again, it doesn't start with hydro, so it does have oxygen. I have my choice between phosphate and phosphite. The OUS ending tells me that this is the phosphite ion. So OUS becomes ITE. So this is the phosphite ion to represent this portion of the phosphorus acid formula. So here's my PO3. It has a -3 charge. Again, because it is an acid, it does have hydrogen. All acids have hydrogen. All of the hydrogen ions in an acid have a +1 charge. So again, I have PO4, which is the phosphite ion with a -3 charge. I have the +1 hydrogen ion. I crisscross. The 3 goes after the hydrogen. There is nothing after the PO3 because I only need one phosphite ion. So this is the formula here for phosphorus acid. And this here is the formula. So this is the formula for phosphoric acid. And this here is the formula for phosphorus acid. All right, now, for some of you, you might find going the other way a lot easier, okay? So again, the same rules apply. If I see a formula, again, I know this is an acid because it has hydrogen combined with a member of group 17. Remember, the hydrogens you are studying in this unit are hydrogen combined with group 17 and maybe sulfur from group 16. So if I look at the formula, I see hydrogen and I see bromine. It does not have oxygen. So when I write the name of the acid, it has to start with hydro. So I write hydrogen, bromine. So these are the two elements that make up my acid. I represent the fact that this is an acid by starting my name with hydro. Again, it doesn't have oxygen. I changed bromine to bromic. So instead of IDE, I changed it to IC, and I give it the last name acid. So again, hydrogen combined with a member of group 17 tells me it is an acid. It does not contain oxygen, so its first name is hydro, followed by the name of the anion, or the non-metallic part of the acid, except I change the ending from IDE to IC, and I give the last name acid. Notice my second example, same thing. I see hydrogen with sulfur. Sulfur is in group 16, but when it combines with hydrogen, it is still treated as an acid. So I have hydrogen, I have sulfur. Because this is an acid without oxygen, I represent that by hydro. And then sulfur becomes sulfuric, and then the word acid. Now, if I have an acid that contains oxygen, how do I know it has oxygen? Well, I look at the formula and I see there's hydrogen, there's oxygen. What I see attached to oxygen is a member of the group 16. So automatically I will be thinking, okay, well, that looks like a polyatomic ion. This is where you have to become familiar. You don't have to memorize the polyatomic ions, but you should become more familiar with and able to recognize them. So when you see them, that's a polyatomic ion. SO4, polyatomic ion. SO3, polyatomic ion. So what you're going to do at this point is you separate out the hydrogen, or you can ignore it for a little while, and you locate SO4 on your polyatomic list. Okay? So SO4 is a sulfate polyatomic ion. When I name this, anything that ended with ATE becomes IC. So sulfate becomes sulfuric, and I give it the last name acid. So this acid that has oxygen has 2 hydrogens, and it doesn't matter, it could have 3 hydrogens and it's still an acid. It could have 1, it's still an acid. So I have hydrogen combined with sulfate to become sulfuric acid. Again, 8 becomes ic. Okay? And then, of course, if I have the sulfite ion, so again, I look at my list, and I see that SO3 is sulfite. ite becomes OUS. So this is the formula for sulfurous acid. The last compound is our hydroxide base. Now, given a hydroxide base, you will see in the formula a metal bonded to a hydroxide. So this OH here is hydroxide, okay, and it has a -1 charge, okay? So when I name it, I just name the metal and follow it by the word hydroxide, just like I named any other ionic compound. Pretty straightforward. So on the test, you will be given the formula and asked to give me the proper name, or I will give you the proper, I give you the formula, you give me the proper name, or I give you the proper name and you give me the formula. And that is all I'm asking for you to be able to do on acids and bases. In terms of can you use the worksheet I had given you, no. All of this will be from your memory. I will not be allowing notes on the test either. So all of those rules that I just talked about and you read about on that handout are going to have to be in your brain. Good luck. Next class, we're going to be playing a little game. So we're going to get into groups. We're going to play a little game to kind of reinforce within you, hopefully, the ability to name compounds and write formulas. 75% of the tests that you will be taking next week are on formula writing or name writing. So we are going to spend some prep time next class on this material. That's it for acids and bases. I hope this helps. Sorry it's so long, but if you have any questions, I will see you when I return to classes on Monday. So stop in to see me and I'll answer any questions. Hui ho!